Okay, hello everyone. My name is Hongyy Zhang. I'm a PhD student of University of Paris, and today I presented my work about the near-infrared backscattering spectrums of dry and wet asphalt. And the objective of my work is to develop a vehicle-mounted system to detect the road surface conditions. And considering the absorption curves of the water in this figure, we investigated the backscattering phenomena of near-infrared light on different road conditions. And in this absorption curves, we can see that near above 1,400 nanometers, there's the absorption coefficient have a peak, and we will exploit this peak to identify different road conditions such as dry or wet. And we did an experiment in our lab, and here is our experimental setup. We use asphalt sample, and it's illuminated by an halogen lamp. The backscattering signal is measured by a near-infrared spectrometer between 900 nanometers to 1,700 nanometers. And we tested for 8 distances between the detector and the asphalt sample. It's between 0.25 to 0.95 meters. And the height of the detector is 6 centimeters. And we also change the positions of the halogen lamp in these five circles, and the detector of the spectrometer is fixed in this graph. And this is a top view of our experiment. And here is the asphalt sample. Thus, we measured 40 different configurations of the backscattering signals. And here is the scene of our experiment. The detector of the spectrometer, the halogen lamp, and the asphalt. We measured for dry, wet, and water asphalt, and the depth of the water is about 1 centimeters. And we use a plastic bag to contain the water. And here is the spectrums. Here is the backscattering reflection of the dry and wet asphalt. And this spectra involves the sensitivity of the spectrometer. So around 900 nanometers and 1,700 nanometers is very low. This is because of the sensitivity of the spectrometer. And we can see from this figure that the shape of the backscattering spectra don't change in different experimental configurations, and the amplitude of dry is much higher than wet. And in order to have a more clearly view, I make average of the spectrums and plotting this figure. The left y-axis is the amplitude of dry. The right axis is the amplitude of wet. And from this figure, we can see that the shape of dry and wet are very similar. And the main difference is between, for example, here 1,300 nanometers and 1,400 nanometers in here. It's between this part. And to make a comparison, we also investigate the water conditions. In this experiment, we changed the illumination source to a collimated halogen lamp because because the normal halogen lamp cannot detect the backscattering backscattering signal, and it has the reflection of the wall by testing by the normal halogen lamp. So we use a collimated halogen lamp. And the amplitude here is higher. This is because of the halogen lamp, because it's collimated. So we cannot compare this to the previous result. And the point is that we can see that there is an obvious decrease above 1,400 nanometers, and this will correspond to the absorption curves of the water. These curves, and but but in this figure, the absorption of water for the wet conditions is not so obvious. So this is our result. And here is a summary from our experiment. The shapes of the backscattering spectra don't change in different experimental configurations, and the amplitude of dry asphalt is much higher than the white, and the backscattering spectra of dry and wet asphalt are very similar, and the backscattering spectra don't show obvious absorption of sorry, here is wet. The backscattering spectra don't show obvious absorption of wet condition, while the backscattering spectrum of water show an obvious absorption. That's all. Thank you. Any questions?
Thank you very much. Is there any question?
C'est un peu étonnant ou pas qu'il n'y ait pas d'effet? Is it surprising that there is no or little effect of wetness on asphalt?
For me, it's a bit surprised.
Yeah.
In the literature, they tested for wet conditions, but some of them didn't test it for the wet asphalt.
Okay. Is there any question? No?
Just a short comment. It reminds me of a very interesting experiment that I've seen 25 years ago at the European Commission, GRC in ISPRA, where they were looking at the height on asphalt, but using microwaves. And the idea was to equip cars, and I think they worked for Mercedes at this time, to equip with a sensor that would in advance tell you if there is ice on the top of a road, and avoid
Yes. Yes, we also investigated ice, so because it's not coherent with this this meeting, so I didn't put the result of ice here.
Okay, thank you again.